This is Module 2, Lesson 4, Part 2. It's a continuation of the discussion of measures of position. And we're going to revisit the graphs that we initially talked about in Lesson 1 of this module. We talked about the stem and leaf plot and the histogram. We're now going to come back and talk about the box plot. The box plot is actually a summary of the five number summary of the descriptive statistics, and it's really the jump start for creating a box plot. The 5 number summary consists of the minimum value of the data set, quartile 1, the median, which is also called quartile 2, quartile 3, and the maximum. That's your 5 number summary. Anytime you're asked for the 5 number summary, you should give the minimum, quartile 1, median, quartile 3, and the maximum. Those numbers can be displayed on a number line, and that creates a visual display called a box plot, or sometimes it's called a box and whisker plot. And one of the key things to remember about the box plot, remember between the minimum and quartile 1, there's always 25% of the data values. Between quartile 1 and the median, there's always 25%. Between the median and quartile 3, there's 25%. And then between quartile 3 and the maximum, you have an additional 25%. Box plots can be displayed either vertically or horizontally. And if you'll notice, it really doesn't matter which way you do it, but box plots, if they're computer generated, will also show an outlier, which you can see here. It's labeled it as an outlier. Again, one of the key things to remember is that between the minimum and the first quartile, you're going to have 25%. Between the first quartile and the median, 25%. Between the median and the third quartile, 25%. Third quartile and the maximum, 25%. And notice sometimes that region is kind of small, other times it's large. The size doesn't matter. There is always 25% within that region from minimum to first quartile and so forth. We'll look at how to create a box plot a little bit later in some of our practice problems. We're going to do that in another video because we're going to let the technology help us to do that. I do want to talk about the z-score or the standard score. The z-score or the standard score is another measure of position that we use throughout statistics and with other things, but it allows us to compare data values even if the measurement scale is different. Again, remember considering if we're considering weights and one measurement is in pounds and one is in grams, or if we're doing something related to perhaps height and you have one in inches and one in centimeters. And it's difficult, you can't make a direct comparison there because they're not the same size unit. So the z-score, or sometimes called the standard score, standardizes that scale. And what it actually does is it converts from pounds or grams to standard deviations. Your unit of measurement for a z-score is the number of standard deviations that your data value is from the mean. Remembering the mean is the measure of center. So there's a formula for calculating the z-score, and we actually would use the z-scores or the standard scores when we begin talking about normal distributions in the next lesson. It was a really important and useful tool before the advent of technology. With technology now, we can sometimes forego the use of the z-score, but you still need to have an understanding of what's going on. The formula for the z-score is you take your original data value x, subtract the mean, get an answer, and then divide by the standard deviation. And we always round z-scores to 2 places. That's a carryover from pre-technology days. prior to technology, we had to use a table to help us solve problems related to z-scores, and the tables were all rounded to 2 decimal places. Otherwise, you had the privilege of doing calculus, which probably none of you want to do. So, when we have the benefit of technology nowadays. So let's look at an example of how we can use a z-score. 3 students were applying to the same graduate school. They came from schools with different grading systems. It looks like maybe Thad attended a school that had used the 4.0 scale. Vicky went to a school perhaps that used a 100-point scale. And Kamala went to one that maybe uses a 9 or 10-point scale. We really don't know, but it's obvious that they weren't the same grading system. And for each student, you've been given their GPA in the second column. You've been given the school average GPA for their school, and then the school's standard deviation. If you think about this in terms of, which one is X, which one is the mean, and which one is the standard deviation, the GPA is your X. Okay. The school average is your mean, and the standard deviation, which is sigma, come on now, is the other value. Okay. So that gives you all of the values that you need, and we're trying to figure out which student has the best GPA. Well, because they have different scales, we can't compare them directly. Okay, so we need to convert them all to a single scale or to the standard z-score, and then we can make a comparison. So we're going to walk through those calculations on the next screen. So for Thad, to calculate his z-score, we would take his GPA, which is given as 2.4, minus the school average GPA of 3.2, and divide it by the school standard deviation, which is 0.8. Make sure you follow order of operations. You would do the subtraction in the numerator first. So you have negative 0.8 divided by 0.8, which is negative 1. The fact that the standard deviation is negative indicates that we're below the average or below the mean. So Thad's GPA is 1, that's the numeric value, 1 standard deviation below the school's GPA. It's not really great. Vicky, if we calculate her z-score, her GPA was 81. The school average GPA for Vicky was 75, divided by the school standard deviation, which was 20. Again, be careful. Follow order of operations. 81 minus 75 is 6. 6 divided by 20 is 0.3. Now, Vicky has a positive score, so obviously hers, without knowing a whole lot, is better than Thad's because at least it's positive. So Vicky's GPA is 0.3 standard deviations above the school's GPA. And finally, Kamala, we took Kamala's GPA, which is 8.7, minus the school average GPA of 8, divided by the school standard deviation, which is 0.4. Do the subtraction in the numerator first. So we have 0.7 divided by 0.4, which is 1.75. Again, it's a positive value. Kamala's GPA is 1.75 standard deviations above the school's GPA. So we can see that if you make the comparison between the three, obviously Vicky and Kamala's are better than Thad because at least they're a positive value, so they're above the average. Between Vicky and Kamala's further away from the average, so she actually has the best GPA compared to other schools or to students at her school, okay, because she's 1.75, or she's the furthest from the school's average GPA.